Now we are going to learn about the Leibniz theorem, which is used for finding nth derivative Okay, so Leibniz theorem is used for finding nth derivative if the function is a product of two or more functions. Now, like let us say, what the theorem says is, let us say if u and v are functions of x, if u and v are functions of x, so then the nth derivative of uv is given by, or this can also be written as uvn, where the down will be denoting the derivative, is equals to uvn plus nc1 into u1 vn minus 1 plus nc2 u2 vn minus 2 plus nc3 u3 into vn minus 3 plus so on plus ncn, so that value is 1, u into or un into v. So this we call it as the nth derivative of the product of two functions given by the Leibniz theorem. So now we'll solve some of the problems how to find out the nth derivative by using our Leibniz theorem. Now let us say if he is asking me to find the nth derivative of x square e to the power x. Let us say he is asking us to find the nth derivative of x square e to the power x. So then, now as we are having a product of two functions, so we can't apply it individually. So then what I'll do is I'll apply the Leibniz theorem by taking u is equals to x square and v is equals to e to the power x. So then the nth derivative of uv or uv of n is given by, so that is uvn plus nc1 into u1 vn minus 1 plus nc2 u2 vn minus 2 plus nc3 u3 into vn minus 3 plus so on plus un into v. So now we go on differentiate these terms like, so the nth derivative of x square into e to the power x is there. So then that is nothing but x square into e to the power x of nth derivative, that is equals to u, say this is u and v, x square into e to the power x of nth derivative plus nc1 into u1. So the derivative of x square is 2x into e to the power x of n minus 1th derivative plus nc2 into derivative of 2x is 2 into e to the power x n minus 2nd derivative plus nc3 into derivative of 2 is 0. So from here all the terms will become 0. So now, so the nth derivative of e to the power x is e to the power x only. So that means no matter what the value of n is, so its derivative will be e to the power x. So then that is d to the power n of x square e to the power x is equals to x square into derivative of e power x is e power x plus the value of nc1, that is n into 2x into again derivative of e to the power x n minus 1 times is again e to the power x plus nc2 n into n minus 1 by 2 into 2 into derivative of e to the power x n minus 2 times is e to the power x, and the remaining terms all are 0. So here 2 and 2 will get cancelled Now from both of these terms, can I take from these three terms, can I take e to the power x common? So then we are left with x square plus 2nx plus n into n minus 1. So which is the nth derivative of x square e to the power x, and which is our required nth derivative. So now, like if we are having a product of two functions, then as we have evaluated in successive differentiations the nth derivative of some standard functions, so we'll be taking or we'll be applying this Leibniz theorem, and we'll be finding out the nth derivatives of u and v, and then we'll substitute in the formula and simplify. We'll be getting the required nth derivative of a function. And especially this Leibniz theorem is used when you are having a product of two functions. Now, so consider the function y is equals to x square, not x to the power n, that is x square sine square x, and he is asking us to find the nth derivative for this function. So now let's, as we are having a product of two functions, so then we have to go with our Leibniz theorem. Now, so given y is equals to x square into sine square x. Now in order to find out the nth derivative, so we don't have an nth derivative of sine square x. So first we have to convert it into the known function whom we have found out the nth derivatives. So then, now can we write this one as x square into, so sine square x can be written as 1 minus cos 2x by 2, or y is equals to x square by 2 minus 1 by 2 into x square cos 2x. So now we have the nth derivative of cos 2x, so then we can apply the Leibniz theorem individually. So then d to the power ny is equals to d to the power n of x square by 2 minus 1 by 2 into x square cos 2x. So the nth derivative of this term will be 0, condition apply that n is greater than 2. So if n is less than or equals to 2, even we have to include these terms. So then that is equals to minus 1 by 2 into d to the power n of x square cos 2x. Now let us say u as x square and v as cos 2x. So then that is equals to, now, so what is our Leibniz theorem? So the Leibniz theorem, is given by d to the power n into uv is equals to uvn plus nc1 into u1 vn minus 1 plus nc2 into u2 into vn minus 2 plus so on plus un into v. So now, like, so if we apply the Leibniz theorem for this, so that means d to the power n into y is equals to minus 1 by 2 times of u vn, that is x square into cos 2x of nth derivative plus nc1 into derivative of x square, that is 2x, into cos 2x of n minus 1th derivative plus nc2 into derivative of 2x is 2 into cos of 2x of n minus 2nd derivative. Now derivative of 2, it will be 0. So then the remaining terms will be 0. So we will be getting only till cos 2x of n minus 2nd derivative. So now we know that the nth derivative of cos ax plus b is given by a to the power n into cos of ax plus b plus n pi by 2. So this was the nth derivative of cos of ax plus b. So which we have learnt in the successive differentiation. So then the value of d to the power ny is equals to minus 1 by 2 times of x square into, so the derivative of cos 2n, nth derivative will be 2 to the power n into cos of 2x plus n pi by 2. Again plus nc1 is n into 2x into cos of n minus 1th derivative will be 2 to the power n minus 1 into cos of 2x plus n minus 1 pi by 2. And again plus nc2 n into n minus 1 by 2 into 2 into cos of n minus second derivative is again 2 to the power n minus 2 into cos of 2x plus n minus 2 pi by 2. So therefore the required nth derivative of x square sin square x will be minus 1 by 2 into, so this is x square 2 to the power n into cos of 2x plus n pi by 2 and plus 2nx, or otherwise 2 to the power n minus 1 can be written as 2 to the power n by 2. So then 2 and 2 will get cancelled. So that is nx into 2 to the power n into cos of 2x plus n minus 1 pi by 2 plus, again here 2 and 2 will get cancelled, that is 2 to the power n minus 2 into n minus 1 into cos of 2x plus n minus 2 pi by 2. So which is the required nth derivative of x square sin square x. Now, so here he is asking us to find the nth derivative of x square log 4x. And now again, as we are having a product of two functions, so then we can go for the Leibniz theorem. So then, so given, let us say y is equals to x square into log 4x. So then, so directly we have the nth derivative of log, so we can directly apply it. So then the derivative, nth derivative of uv according to Leibniz theorem is given by uvn plus nc1 into u1 into vn minus 1 plus nc2 into v2 into, u2 into vn minus 2 plus nc3 into v3 into un minus 3 plus so on plus 1 into un into v. So this is the nth derivative of the function u into v. So now let us say u is x square and v is log 4x. So now let us find out the nth derivative of log ax plus b. So the nth derivative of log of ax plus b is given by minus 1 to the power n minus 1 into n minus 1 factorial into a to the power n by ax plus b to the power n. This is the nth derivative of log. So then let's apply the formula for x square log 4x. So keep this value aside. So then the nth derivative of x square log 4x is equals to uvn, that is x square into log 4x of nth derivative plus nc1 into derivative of x square, that is 2x, into derivative of log 4x of n minus 1th derivative plus nc2 into derivative of 2x is 2 into log 4x of n minus second derivative NC3 into derivative of 2 is 0. So from here the remaining terms are zeros. So the nth derivative of y is equals to x square. Now, so the nth derivative of log of 4x, so that will be the value of a is 4. So then that is minus 1 to the power n minus 1 into n minus 1 factorial. So we said the value of a is how much? So here the value of a. So the value of a is 4. So then that is 4 to the power n by 4x whole to the power n plus NC1. So the value of NC1 is n into 2x into, now the derivative of log of 4x n minus 1. So then that is minus 1 to the power n minus 2 into n minus 2 factorial into a to the power, that is 4 to the power n minus 2 by 4x to the power n minus 2 plus NC2 value, that is n into n minus 1 by 2 into 2 into, now the n minus second derivative of, so I think this is 1, n minus 1. So now, so n minus second derivative will be minus 1 to the power n minus 3 into n minus 3 factorial into 4 to the power n minus 2 by 4x to the power n minus 2. So then, if we simplify these terms, the 2 will get cancelled. Again, from this, if we take out 4 common, so that will be 4 to the power n and 4 to the power n will get cancelled, and so 4 to the power n minus 1, and so 4 to the power n minus 2 and n minus 2, 4 to the power. So then the value of d to the power ny will be x square into minus 1 to the power n minus 1 into n minus 1 factorial by 4 to the power n, 4 to the power n will get cancelled, x to the power n plus 2 and x into minus 1 to the power n minus 2 into n minus 2 factorial by x to the power n minus 2, and again plus n into n minus 1 into minus 1 to the power n minus 3 into n minus 3 factorial by x to the power n minus 2. So then, if we simplify this further, or if we want it, we can keep it as it is, or if we want to simplify it further, so then this equals to, what I'll do is, so this is n minus 1. Now, what I'll do is, I'll divide with x, so then that will be minus 1 to the power n minus 1 into n minus 1 factorial by x to the power n plus minus 1 to the power n minus 2 into n minus 2 factorial into, I brought this x down, so that is 2n by x to the power n minus 2, and here we brought it x down, that is x to the power n minus 2 plus n into, or minus 1 to the power n minus 3 into n minus 3 factorial n into n minus 1 by x to the power n minus 2. So if we bring d to the power ny minus 1 to the power n minus 1 by x to the power n minus 2 common, so then here we will be getting it as n minus 1 factorial plus n minus, so as minus n minus 1 came out, here it will be minus n minus 2 factorial into 2n, and here this will be plus, this is n minus 3 factorial into n into n minus 1. So this is the required nth derivative of x square log 4x. Now, we'll look into the concept by using the Leibniz theorem, that how to establish the relation between yn plus 2, yn plus 1 and yn. So how to establish the relation between all these three. So that's we are going to learn now. Now remember, so that is d to the power n of y2. So remember this as a note points. D to the power n y2 will be equals to yn plus 2, and d to the power n y1 is equals to yn plus 1, and again d to the power n plus 1 y1 will be yn plus 2, and d to the power n plus 1 y will be yn plus 1. And so like this, if we go on writing, we'll be getting different relations for yn plus 2, yn plus 1, yn and so on. Okay. So now we'll solve some of the questions by using the Leibniz theorem, how to obtain the relation between yn plus 1 and yn plus 2. Now, so given y is equals to sine inverse x whole square, and is asking us to prove that 1 minus x square y2 minus xy1 is equals to 2, and also is asking us to prove and apply the Leibniz theorem to find out the nth derivative of a function. Now, say given y is equals to sine inverse of x whole square. Now let us find out the value of y1 and y2. So the value of y1, so the derivative of sine inverse x whole square is 2 into sine inverse x into derivative of sine inverse x 1 by root over 1 minus x square. Or if I bring 1 minus x square this side, root over into y1 is equals to 2 into sine inverse x. Now let us keep this value aside. Now I'll differentiate this again. So if we are differentiating again with respect to x, so here we have differentiated with respect to x, so we got the value of y1, and then we have rewritten this one. Now again I am differentiating with respect to x, so again here you have to apply UV formula, so that is root over 1 minus x square into derivative of y1 is y2 plus y1 into derivative of root, that is 1 by 2 root 1 minus x square into derivative of 1 minus x square is 2x is equals to 2 into derivative of sine inverse x 1 by root over 1 minus x square. Or, so if we simplify this, so then I'll take the LCM here. So that will be 2 will get cancelled. Root over 1 minus x square into root over 1 minus x square, that is 1 minus x square y2 plus here we are having x into y1 by root over 1 minus x square. I think here we will be getting derivative of 1 minus x square as 2. So then this will be minus 2xy1 by root over 1 minus x square equals to 2 by root over 1 minus x square. So again root over 1 minus x square, root over 1 minus x square will get cancelled. So therefore we are getting 1 minus x square into y2 minus x into y1 is equals to 2. So this is what he asked us to prove. So hence, which is our required proof. So which is the required proof. Now again he is asking us to find the nth derivative. So then what I'll do is I'll apply the nth derivative for this. So that means, so if we are apply nth derivative, so then what do we get? D to the power n of 1 minus x square y2 minus x into y1 is equals to d to the power n into 2. So then, if we apply it, so that is d to the power n into 1 minus x square into y2 minus d to the power n into x into y1, the nth derivative of a constant is 0. Now, here I'll apply the Leibniz theorem to find out the nth derivative for the product of two functions. So what is our Leibniz theorem? That is d to the power n into uv, that is uvn plus nc1 into uvn minus 1 plus nc2 into uvn minus 2 plus so on plus unv. So that is the nth derivative by using our Leibniz theorem. Now here in this one I'll consider u to be 1 minus x square and v to be yn. So then that implies uvn, that is 1 minus x square into, now earlier I said dn of y2, that will be yn plus 2 plus nc1 into, so nc1 into derivative of 1 minus x square, that is minus 2x into the derivative or y2 of n minus 1 plus nc2 into derivative of minus 2x, so that is minus 2 into derivative of y2 of n minus 2. Let us keep this as yn of n. Sorry, y2 of n. Now again, so minus, coming to this, so that is x into y1 of n plus derivative of x is 1 into y1 of nc1 into y1 of 1 n minus 1 is equals to 0. Now simplify these terms. So that is 1 minus x square into y n plus 2 minus 2nx. The value of nc1 is n. So 2nx into y2 n minus 1 can be written as y n plus 1, and again minus 2 into nc2 n into n minus 1 by 2 into y2 of n minus 2 is again yn, and minus x into y1 of n, that is y of n plus 1 minus nc1, that is n, y1 of yn minus 1 is yn, is equals to 0. So here 2 and 2 will get cancelled. Now rearrange the terms, x, yn plus 2, yn plus 1, yn terms. If we rearrange them, so then what do we get? 1 minus x square into yn plus 2. Now, for coming to yn plus 1 terms, so I'll take out yn plus 1 minus with minus common. So that will be 2nx plus x into yn plus 1. And here again minus yn if I take out common. So then that will be, this is n square minus n square minus n plus n into yn is equals to 0, or that implies 1 minus x square into yn plus 2 minus x into 2n plus 1 into yn plus 1. So plus n minus n both will get cancelled, minus n square into yn is equals to 0. So which is our required nth derivative, which we got it by the Leibniz theorem. So, or differentiating the given function n times. So this is what we are getting. Now, let us say is asking us to prove 1 plus x square y2 plus 2x y1 is equals to 0. Now, so let us say he has given tan y is equals to x. So that implies, can I write y is equals to tan inverse x? So if we differentiate this with respect to x, so then the derivative of y will be y1 is equals to derivative of tan inverse x 1 by 1 plus x square, or I'll write this as 1 plus x square into y1, 1 plus x square into y1 is equals to 1. Now keep this value aside. So then again, so I'll differentiate this again. So again, differentiating with respect to x. So if we are differentiating again with respect to x, so then what do we get? Apply UV formula for this. 1 plus x square into derivative of y1 is y2 plus derivative of 1 plus x square, that is 2x, into y1 is equals to derivative of 1 is 0. So this is what he asked us to prove, that is 1 plus x square y2 plus 2x y1 is equals to 0. So which is the required proof. So these are required proof of 1. Now in order to get the higher order derivatives, so what we'll do is we'll be applying or we'll be differentiating this n times. Now like, so then apply the nth derivative on both sides in order to get the second one. So then if I am applying the nth order derivative or nth derivative, so then what do we get? That is 1 plus x square into y2 plus 2x into y1 is equals to 0. Now, so then apply it individually, so that is d to the power n of 1 plus x square into y2 plus d to the power n into 2x into y1 is equals to 0. Now as we are finding out the nth order derivative, and here we are having a product of two functions, so then we'll be applying the Leibniz theorem. So the Leibniz theorem is given by, so the Leibniz theorem is given by d to the power n of uv is equals to uvn plus nc1 into u1 vn minus 1 plus nc2 u2 into vn minus 2 plus so on plus vun into v. Now for the first one, if I consider, so that will be for the first one, so then that is 1 minus x square, sorry 1 plus x square into y2 of nth derivative plus nc1 into derivative of 1 plus x square, that is 2x, into y2 of derivative of n minus 1th derivative plus nc, this is nc1, nc2 into derivative of 2x, that is 2 into y2 of n minus second derivative, and if we are going for higher, so derivative of 2 is 0, so then that will be the last. Now again for this, that is plus 2x into y1 of nth derivative plus nc1 into derivative of 2x is 2 into y1 of n minus 1th derivative, derivative of 2, that is 0. So from here all the terms will become 0. Now let's simplify these terms. So then that will be 1 plus x square into y2 of nth derivative is yn plus 2 plus nc1, that is n, into 2x into y2 of n minus 1th will be yn plus 1 and nc2, that is n into n minus 1 by 2 into 2 into y2 of n minus 2, that is yn plus 2x into y1 of n is yn plus 1, nc1, that is n into 2 yn is equals to 0. So here 2 and 2 will get cancelled. Now rearrange the terms, yn plus 1 terms and yn terms. So then we'll be getting it as 1 plus x square into yn plus 2, and from these two can we take out 2x common? So then that will be n plus 1 into 2x into yn plus 1, and from these two I'll take out n into yn common. So then we'll be left with n minus 1 plus 2 into yn is equals to 0, or so that implies 1 plus x square into yn plus 2 plus n plus 1 into 2x into yn plus 1 plus n into n plus 1 into yn is equals to 0. So this is what he asked us to prove. So which is the required proof. Now, so consider y is equals to x square minus 1 to the power n. So he is asking us to prove that is 1 minus x square yn plus 2 minus 2x into yn plus 1 plus n into n plus 1 into yn is equals to 0. So now, given y is equals to x square minus 1 to the power n. Now as I am having power term, so what I will do is I will apply log on both sides. So no problem, we can directly substitute also, we can directly differentiate also. But in order to make it simplified, so then I will be taking log on both sides. So then log y is equals to n into log of x square minus 1. So if we differentiate with respect to x, so if we are differentiating with respect to x, so then derivative of log y, that is 1 by y, into derivative of y is y1 is equals to n into derivative of log will be 1 by x square minus 1 into derivative of x square minus 1, which is 2x. So if I rewrite these terms, so that is x square minus 1 into y1 is equals to 2nx. So then let us keep this value aside. Now again let's differentiate this with respect to x. So this is 2nxy. So we brought this y this side. So now again if we are differentiating with respect to x, so if we differentiate this with respect to x, again apply UV formula, that is x square minus 1 into y2 plus y1 into derivative of x square, that is 2x, is equals to 2n into, apply UV formula for this, x into y1 plus y into derivative of x is 1. So if we simplify this, so this is x square minus 1 into y2 plus 2x y1 minus 2nx y1 again minus 2ny is equals to 0. So then that will be, so x square minus 1 into y2 plus, so from these two terms can we take ny1 common, sorry x2 xy1 I will take out common, so that is 2 times of here 1 minus n into xy1 minus 2ny is equals to 0. So this is the relation between y1 and y2. Now again after differentiating n times, so if we are differentiating n times, so then that will be d to the power n into x square minus 1 into y2 plus 2 into n minus 1, sorry 1 minus n into d to the power n into xy1 minus 2n into d to the power n into y is equals to 0. Now as we have to find the nth derivative, so we will be applying, So the Leibniz theorem, which is given by the nth derivative of uv is uvn plus nc1 into u1 into vn minus 1 plus nc2 into u2 into vn minus 2 plus so on plus nc1 or ncn, that is 1, un into v. So these are Leibniz theorem. Now we'll apply Leibniz theorem for each and every term. So then that will be, so if we are applying Leibniz theorem for the first term, that will be x square minus 1 into y2 of nth derivative plus nc1 into derivative of x square minus 1, that is 2x, into y2 of n minus 1th derivative plus nc2 into derivative of 2x, that is 2, into y2 of n minus 2nd derivative, and if we go for further derivative of 2, that will be 0, plus 2 into 1 minus n into, now again, so apply Leibniz theorem for this, so that is x into y1 of n plus nc1 into derivative of x is 1, y1 of n minus 1 plus derivative of 1, that is 0, so we'll stop it here, minus 2n into yn is equals to 0. Now, so that will be x square minus 1 into yn minus 2 plus nc1 value is n into 2x into yn plus 1 plus nc2 into 2, that is n into n minus 1 into yn. Now again, so here plus 2 into 1 minus n into, so this is x y n plus 1 plus nc1, that is n, y1 of n minus 1, that is yn, minus 2n yn is equals to 0. Now rearrange the terms yn plus 2, yn plus 1 and yn terms. So then that will be x square minus 1 into yn plus 2 plus, so if we take from these two, so we can take out x common and again 2 common. So if we are taking x and 2 common, so then what we are getting, that is 2x, and here n will be left out, and here 1 minus n will be left out. So plus 1 minus n into yn plus 1, and again from these three terms, yn if we take out common, that is n into n minus 1, here plus 2n minus 2n square into yn, again minus 2n into yn is equals to 0. So then that implies x square minus 1 into yn minus 2 plus this one, n and n will get cancelled. So then we will be left with 2x into yn plus 1, and again here, so from all the terms we can take out n common, so plus 2n minus 2n will get cancelled. So then from all the terms, if I am taking n common, so then we are left with n minus 1 minus n 2n minus 2n into yn is equals to 0, or that will be x square minus 1 into yn plus 2 plus 2x into yn plus 1 plus n into, this is minus n minus 1 into yn is equals to 0. Now I will take out minus common, or throughout I will multiply with minus. So then as we are multiplying with minus, so then that will be 1 minus x square into yn plus 2 minus 2x into yn plus 1 plus n into n plus 1 into yn is equals to 0. So which is our required proof by using Leibniz theorem. Now consider the function x is equals to tan of log x, and he is asking us to find the value of 1 plus x square into yn plus 1 plus 2nx minus 1 into yn plus n into n minus 1 into yn minus 1. Now, as in order to get this value, we will be applying the Leibniz theorem for the nth derivative of the product of two functions. And if we look into this one, here we are having yn minus 1. So then, as we are having yn minus 1, so we will establish a relation between y and y1. So once we establish the relation between y and y1, and if we apply the nth derivative, then we will be getting the terms of n minus 1. Or if we are establishing the terms till y1, y2 and y3, or y1 and y2, so then we will be getting a relation between yn plus 2, yn plus 1 and only yn. Then we won't be getting any relation with yn minus 1. Now in order to get the relation with yn minus 1, so what we will be doing is we will establish a relation between y1 and y. So now given the function x is equals to tan of log y. Now since he gave x as tan of log y, so we want a relation for y. So first get the value of y. So then can I write this one as log y is equals to tan inverse of x, and in the same way y is equals to e to the power tan inverse x. So this is the value of y. Now, so let us find out the value of y1. So the derivative of y is y1 is equals to derivative of e to the power tan inverse is e to the power tan inverse 1 x into derivative of tan inverse x 1 by 1 plus x square. Or can I write this one as, I will bring 1 plus x square this side into y1 is equals to e to the power tan inverse x is y. Say this is a relation between y and y1. Now in order to get yn minus 1, so we will just establish a relation between y and y1. Now apply the nth derivative or differentiate till n times. So differentiate till n times. So if we are differentiating till n times, so then what do we get? We will be getting it as d to the power n into 1 plus x square into y1 minus d to the power n into yn is equals to 0. Now, as here we are having a product of two functions, so then we will be applying the Leibniz theorem. Now, what is the Leibniz theorem? D to the power n into uv is equals to u into vn plus nc1 into u1 into vn minus 1 plus nc2 into u2 into vn minus 2 plus so on plus un into v. So now let us consider 1 plus x square as u and y1 as v. Now we will apply the Leibniz theorem for this term. So then that will be 1 plus x square into d to the power n into y1 plus nc1 into derivative of 1 plus x square, that is 2x, into d to the power n minus 1, d to the power n minus 1 into y1 plus NC2 into derivative of 2x, that is 2, into d to the power n minus 2 into y1 plus minus d to the power n into y is equals to 0, or that implies 1 plus x square into d to the power n y1, that is d to the power n plus 1 plus nc1, that is n into 2x into d to the power n minus 1 y1, that is yn, plus nc2, that is n into n minus 1 by 2 into 2 into d to the power n minus 2 y1 is yn minus 1 minus d to the power n y is yn is equals to 0. Now I'll take out yn common, so then that will be 1 plus x square into yn plus 1 plus, if we are taking out yn common, that is 2nx minus 1 into yn plus 2 and 2 will get cancelled, that is n into n minus 1 into y, n minus 1 is equals to 0. So this is what he asked us to find. So then the value of 1 plus x square into yn plus 1 plus 2n minus 1 into 1 yn plus n into n minus 1 into yn minus 1 value is 0. So that is our required value. So given y is equals to sine of log of x square plus 2x plus 1, and he is asking us to prove that x plus 1 whole square into yn plus 1 plus 2n plus 1 into x plus 1 into yn plus 1 plus n square plus 4 into yn is equals to 0. And this question was asked in Jan 2014 and July 2016. So then, given the value of y is equals to how much? That is sine of log of x square plus 2x plus 1. Now here he is asking the relation between yn plus 2, yn plus 1 and yn. So we'll find out the values of y1, y2 and y1 and y2. Now, so in this he is asking the relation between yn plus 2, yn plus 1 and yn. So we'll establish a relation between y, y1 and y2, and then we'll be applying the nth order derivative, and by using our Leibniz theorem we can come to the required value. So then, given y is equals to sine of x square plus 2x plus 1, so then y1, so the derivative of sine is cos of log of x square plus 2x plus 1 into derivative of log 1 by x square plus 2x plus 1 into derivative of x square plus 2x, so that is 2x plus 2. Now, can I write y1 as cos of log of x square plus 2x plus 1 into 1 by, so this term can be written as x plus 1 whole square into, I'll take out 2 common from this, so then that will be x plus 1. So x plus 1 and square will get cancelled. I'll bring x plus 1 this side. So that will be x plus 1 into y1 is equals to 2 into cos of log of x square plus 2x plus 1. Now again we'll differentiate this. So if we are differentiating, so apply UV formula, that is x plus 1 into derivative of y1 is y2 plus y1 into derivative of x plus 1 is 1 is equals to 2 into, now derivative of cos, sine, minus sine. So minus of log of x square plus 2x plus 1 into derivative of log, that is 1 by again x square plus 2x plus 1 can be written as 1 plus x whole square into derivative of x square plus 2x plus 1, that is 2x plus 2. So then if we rearrange this term, so that is x plus 1 into y2 plus y1 minus 2 into is equals to minus 2 into, now sine of log of x square plus 2x plus 1, can I write it as y? So then this term I will be writing it as y into, again from this if I take out 2 common, that will be x plus 1 by x plus 1 whole square. So x plus 1 and square will get cancelled, and so bring x plus 1 this side, so that will be x plus 1 whole square into y2 plus x plus 1 into y1, and again here this is minus 4y, if that comes that side, so that is plus 4y is equals to 0. Now in this way apply n derivatives. So if we apply n derivatives, so then what do we get? That is d to the power n into x plus 1 whole square into y2 plus d to the power n into x plus 1 into y1 plus 4 into d to the power n into y is equals to 0. So now as we are having the product of two functions and we are finding out the nth order, so we will be applying Leibniz theorem. So apply Leibniz theorem. So what is this Leibniz theorem? That is d to the power n into uv is equals to u vn plus nc1 into u1 vn minus 1 plus nc2 into u2 into vn minus 2 plus so on plus unv. So then if we apply Leibniz theorem for individual terms, so then that will be for this. So u is 1 plus x whole square, so that is x plus 1 whole square into y2 of nth derivative plus nc1 into derivative of x square plus 1 whole square, that is 2 into x plus 1 into y2 of n minus 1th derivative plus nc2 into derivative of 2 into x plus 1, that is 2 into y2 of n minus 2 plus again apply Leibniz theorem for this, so that is x plus 1 into y1 of nth derivative. So for this nc1 into derivative of x plus 1 is 1 into y1 of n minus 1 plus 4 into d to the power ny is yn is equals to 0. Now if we rewrite this term, so that is x plus 1 whole square into yn plus 2 plus nc1 is n into 2 into x plus 1 into yn plus 1, and here plus nc2, that is n into n minus 1 by 2 into 2 yn, and again from this plus x plus 1 into yn plus 1 plus nc1 is n into yn plus 4 into yn is equals to 0. So here 2 will get cancelled. Now write all yn plus 1 terms, yn and yn plus 2 terms. So then that is x plus 1 whole square into yn plus 2. Now, so from these two terms, can I take x plus 1 into yn plus 1 common? So if we are taking x plus 1 into yn plus 1 common, so then here 2n is left and here 1 is left. That is 2n plus 1 into x plus 1 into yn plus 1, and again. So from all these three, I'll take out yn term common. So if we are taking yn common, so then that will be plus n into n square minus n plus 4 into yn is equals to 0. Or, so therefore, that is x plus 1 whole square into yn plus 2 plus 2n plus 1 into x plus 1 into yn plus 1 plus again. So here we miss this n. So this is plus n plus 4. So minus n plus n will get cancelled. So that is n square plus 4 into yn is equals to 0. So which is our required value. Now, say he has given y is equals to x plus root over x square minus 1 to the power m, and he is asking us to prove the following. That is x square minus 1 into yn plus 2 plus 2n plus 1 into x into yn plus 1 plus n square minus m square into yn is equals to 0. And this question was asked in the year Jan 2016. So now, given y is equals to x plus root over x square minus 1 to the power n. Now, so as I am having power m, so I'll apply log on both sides. So if we apply log on both sides, so then that will be log y is equals to m into log of x plus root over x square minus 1. So now we'll obtain the relation between y, y1 and y2. So then if we differentiate this, so then if we differentiate with respect to x, so then what do we get? So the derivative of log y, that is 1 by y, into derivative of y is y1 is equals to m into derivative of log 1 by x plus root over x square minus 1 into derivative of x, so that is 1, plus derivative of root, that is 1 by 2 root x square minus 1 into derivative of x square minus 1, that is 2x, or 1 by y into y1 is equals to m by x plus root over x square minus 1 into, so 2 and 2 will get cancelled. So if we take the LCM, so what is the LCM? That is root over x square minus 1 is the LCM, and here this will be root over x square minus 1 plus x. So then x plus root over x square minus 1, x plus root over x square minus 1 will get cancelled. Now if we cross multiply it, so that is root over x square minus 1 into y1 is equals to m into y. So now we'll again, so this is y, not y1. So now we'll differentiate again with respect to x. So if we differentiate again, or instead of differentiating, now apply squaring on both sides. So then if we square it on both sides, so that will be x square minus 1 into y1 square is equals to m square y square. Now we'll differentiate again with respect to x. So if we are differentiating again with respect to x, so then that will be, so that is x square minus 1 into derivative of y1 square, that is 2y1 y2 plus y1 square into derivative of x square plus x square minus 1, that is 2x, is equals to m square into derivative of y square, that is 2y y1. Or can I write this one as 2 into x square, and again, so can I take 2y common from the whole? So if we are taking 2y common, so then that will be x square minus 1 into y2 plus x into y1 is equals to 2m square y into y1, or, so we have taken y1 common, or this can be written as x square minus 1 into y2 plus xy1 is equals to m square y. Now we got a relation between y1 and y2. Now apply, differentiate it n times. So n times, if we differentiate it, so then that will be d to the power n into x square minus 1 into y2 plus d to the power n into xy1 is equals to m square into d to the power n into y. Now we'll apply the Leibniz theorem as we are having the product of two functions. So then, as we are having the product of two functions, so then the nth derivative of uv is given by uvn plus u1 nc1 into u1 vn minus 1 plus nc2 into u2 into vn minus 2 plus so on plus un into v. So then, let us say this is u and v. So if we apply the Leibniz theorem for this, so then that will be x square minus 1 into y2 of nth derivative plus nc1 into derivative of x square minus 1 is 2x into derivative of y2 n minus 1 times plus nc2 into derivative of 2x, so that is 2 into y2 of n minus 2 second derivative, and again if we differentiate it further, the derivative of 2 will be 0. So plus again derivative of x into y, so that is x into y1 of nth derivative plus nc1 into derivative of x is 1, y1 of n minus 1th derivative is equals to m square into yn. And if we simplify this further, that is x square minus 1 into yn plus 2 plus nc1 is n, so that is 2nx into yn plus 1, and nc2 into 2, that is plus n into n minus 1 into yn plus x into yn plus 1 plus n into nc1 is n into yn is equals to m square yn. Now we'll rearrange the terms, like bring all yn plus 1 terms separately and yn terms separately. So now if we rearrange the terms as x square minus 1 into yn plus 2 plus take yn plus 1 terms. So from these two, can I take out x into yn plus 1 common? So then we are left with 2n plus 1 into x into yn plus 1. And again, I'll bring m square this side, or otherwise first let us take yn common or n into yn common from them, or otherwise, so we'll multiply that. So then that will be plus n square minus n plus n into yn minus m square yn is equals to 0. So I brought this term this side. So then that will be x square minus 1 into yn plus 2 plus 2n plus 1 into x into yn plus 1. So minus n plus n will get cancelled. From these two I'll take out yn common. That will be n square minus n square into yn is equals to 0. So which is our required proof. Now, so consider sin y is equals to 2 log of x plus 1, and he is asking us to prove x plus 1 whole square into yn plus 2 plus 2n plus 1 into x plus 1 into yn plus 1 plus n square plus 4 into yn. So this question was asked in Jan 13 and Jan 15, or the same question was asked in January 2014 and July 2016 as y is equals to sin of log of x square plus 2x plus 1. So the same question was asked 4 times, but 2 ways in this way and in 2 ways in this way. So totally this question was asked 4 times. So now, so this one, so that is sin inverse y is equals to 2 log of x plus 1 can be written as y is or sin inverse y is equals to log of x plus 1 whole square, or the value of y will be sin of log of again x plus 1 whole square. So if we expand x plus 1 whole square, it will be x square plus 2x plus 1. So let us say these are equation 1 given 1. Now differentiate with respect to x. So if we are differentiating with respect to x, so then this will be y1 is equals to derivative of sine, that is cos of log of x plus 1 whole square into derivative of log, that is 1 by x plus 1 whole square into derivative of x plus 1 whole square, that is 2 into x plus 1. So x plus 1 and square will get cancelled. I'll bring x plus 1 this side. So then that will be x plus 1 into y1 is equals to 2 into cos of log of x plus 1 whole square. Now again I'll differentiate this. So again differentiating with respect to x. So then apply UV formula, that is x plus 1 into derivative of y1 is y2 plus derivative of x plus 1 is 1 into y1 is equals to minus 2 into derivative of cos is minus sin of log of x plus 1 whole square into derivative of log, that is 1 by x plus 1 whole square into derivative of x plus 1 whole square is 2 into x plus 1. So x plus 1 and square will get cancelled. Now again I'll bring x plus 1 this side. So then that will be x plus 1 whole square into y2 plus x plus 1 into y1 is equals to. Now from 1 can I write sin of log of x plus 1 whole square as y? So then this term I'll write it as y. So then 2 into 2, so that is minus 4 into y. So this is the relation between y, y1 and y2. So then, now in the same way I'll be going on applying the derivatives. So applying n derivatives. So then that will be d to the power n into, this will be x plus 1 whole square into y2 plus d to the power n into x plus 1 into y1 is equals to minus 4 into nth derivative of y. So then, as we are having the product of two terms, that is x plus 1 whole square and y2. In order to find the nth derivative, we'll be applying Leibniz theorem. So we'll be applying Leibniz theorem. So where the Leibniz theorem is given by nth derivative of uv is equals to u vn plus nc1 into u1 vn minus 1 plus nc2 into u2 into vn minus 2 plus so on plus un into v. So then, now apply Leibniz theorem for each and every term. So then this is, that implies x u into vn. So x plus 1 whole square into y2 of nth derivative plus nc1 into derivative of x plus 1 whole square is 2 into x plus 1 into y2 of n minus 1th derivative plus nc2 into derivative of 2x plus 1 is 2 into y2 of n minus 2nd derivative plus if we differentiate 2, that will be 0. Now again apply Leibniz theorem for this term. So that is plus x plus 1 into y1 of nth derivative plus derivative or nc1 into derivative of x plus 1 is 1 and y1 of n minus 1th derivative is equals to 4 into minus 4 into nth derivative of y is yn. Now if we simplify this, so then that is equals to x plus 1 whole square into y n plus 2 plus nc1 is n into 2 into x plus 1 into y n plus 1 plus nc2 is n into n minus 1 by 2. So 2 will get cancelled. This value is yn plus x plus 1 into y n plus 1 and again nc1 value is plus n into yn is equals to minus 4 into yn. Now bring all yn plus 2, yn plus 1 and yn terms separately. So then that implies x plus 1 whole square into yn plus 2 plus, now so from these two terms I'll take out x plus 1 into yn plus 1 common. So then we are left with 2n plus 1 into x plus 1 into yn plus 1 and if we take out all the yn terms common, so then that will be plus n square minus n plus n minus 4 into yn is equals to 0. So minus n plus n will get cancelled. So that implies x plus 1 whole square into yn plus 2 plus 2n plus 1 into x plus 1 into yn plus 1 plus n square minus 4 into yn is equals to 0. So this is what he asked us to prove. So this is our required proof. Now consider y is equals to cos of m log x and he is asking us to prove that x square yn plus 2 plus 2n plus 1 into x yn plus 1 plus n square into yn is equals to 0. And this question was asked in the year Jan 2015. Now first we'll rebuild a relation between y, y1 and y2 and then later on we'll be applying the nth derivatives. So then let us say given y is equals to cos of m log x. Now can I write cos of m log x as cos of log x to the power m? Let us say these are equation 1. Now So differentiate 1 with respect to x. So if we are differentiating 1 with respect to x, so then that will be y1 is equals to derivative of cos, that is minus sine of log x to the power m, into derivative of log, that is 1 by x to the power m, into derivative of x to the power m, m into x to the power m minus 1. Now if we simplify this, so that is y1 is equals to minus m into sine of log of x to the power m into x to the power m minus 1 by x to the power m, that is 1 by x. I'll bring x this side, so then that will be xy1 is equals to minus m into sine of log x to the power m. Yes? Now differentiate again with respect to x. So again differentiate with respect to x. So if we are differentiating again with respect to x, so then that will be x into y2 plus derivative of x is 1 into y1 is equals to minus m into cos of log, sine of log. So derivative of sine, that is cos of log of x to the power m into derivative of log 1 by x to the power m into derivative of x to the power m, m into x to the power m minus 1. Now again, if we simplify this, so then that will be xy2 plus y1 is equals to minus, again, cos of log x to the power m. Cos of log x to the power m, we can write it as y. So then from 1, I'll write this term as y. So m into y into m into x to the power m minus 1 by x to the power m, that is 1 by x. And if we rewrite that in a simplified way, so then bring x this side, so then that will be x square y2 plus x into y1, and this is minus plus m square y is equals to 0. So now, as we have obtained the relation between y, y1, y2, so differentiate again n times. So differentiating n times, what do we get? So that is d to the power n into x square y2 plus d to the power n into x y1 plus m square into d to the power n y is equals to 0. So now, as we are having the product of two functions and we are finding the nth derivative, so then we will be applying Leibniz theorem. Now what is this Leibniz theorem says? That is nth derivative of uv is equals to u vn plus nc1 into u1 vn minus 1 plus nc2 into u2 into vn minus 2 plus so on plus un into v. Now if we apply Leibniz theorem for each and every term, so then let us consider x square as u, y2 as v. So then that is x square into y2 of nth derivative plus nc1 into derivative of x square, that is 2x, into y2 of n minus 1th derivative plus nc2 into derivative of 2x, that is 2, into y2 of n minus 2nd derivative plus, again if we go further, derivative of 2, 0, so the remaining terms will become 0. Again plus, now again apply Leibniz theorem for this. So that is nx into y1 of nth derivative plus nc1 into derivative of x is 1, y1 of n minus 1th derivative plus, again if we go further, that will be zeros. So then m square into y of nth derivative is equals to 0. Now let's rewrite the terms. So then that is x square into y2 of nth derivative is yn plus 2 plus nc1 that is n, so 2xn into y2 of n minus 1 is n plus 1 plus nc2 that is n into n minus 1 by 2 factorial. So 2 and 2 will get cancelled. y2 of n minus 2 is yn plus x into yn plus 1. And again from this that will be plus n into y1 of n minus 1 derivative is yn plus m square into yn is equals to 0. Now arrange the terms as bring all yn plus 1 terms and yn terms. So then that will be x square into yn plus 2 plus, now from both of these terms can I take out x into yn plus 1 common? So if you are taking x into yn plus 1 common, so then here it will be 2n plus 1 into x into yn plus 1. Now again from all these three terms I'll take out yn common, so then that will be plus n square minus n plus n plus m square into yn is equals to 0. So minus n plus n will get cancelled. So then that is x square into yn plus 2 plus 2n plus 1 into x into yn plus 1 plus n square plus m square into yn is equals to 0. So this is what he asked us to prove. Now consider x is equals to sine t, y is equals to sine pt. So the curves are in the parametric form, and he is asking us to prove that 1 minus x square into yn plus 2 minus 2n plus 1 into x into yn plus 1 plus p square minus n square into yn is equals to 0. And this question was asked in the month of July 2014. So now as the curves are in the parametric form, let us say x is equals to sine t and y is equals to sine pt. So now what I'll do is, from the first equation, can I write t is equals to sine inverse of x? Now I'll substitute in the second equation. That means the value of y is sine p into t can be written as sine inverse x. Okay, so we got the value of y in terms of x. Now let us say these are equation 1. So now differentiate 1 with respect to x. So if we are differentiating 1 with respect to x, so then that will be y1 is equals to derivative of sine, that is cos of p sine inverse x into derivative of p sine inverse x is p into 1 by root over 1 minus x square. Or, so that is y1 into, I'll bring this term here, root over 1 minus x square is equals to p into cos of p into sine inverse x. Now again, now I'll square it on both sides. So if I am squaring on both sides, so then that will be 1 minus x square into y1 square is equals to p square into cos square of p into sine inverse x. Now what I'll do is, I'll differentiate this again. Let us say these are equation 2. Now if we differentiate it again, so then that will be, so differentiating with respect to x. So if we are differentiating with respect to x, so then that will be, apply uv, that is 1 minus x square into 2y1 y2 plus y1 square into derivative of 1 minus x square is minus 2x is equals to p square into derivative of cos square is 2 into cos of p into sine inverse of x into derivative of cos, so that is minus sine into p into sine inverse x into derivative of, so the derivative of p sine inverse x, so that is p into 1 by root over 1 minus x square, or so then this will be 1 minus x square into 2y1 into y2 minus 2xy1 square is equals to 2 into p cube into, again, now cos of p or p into cos of p sine inverse x can be written as y1 into, so that is y1 into root over 1 minus x square. Now here I am writing this p as p into cos of p sine inverse x. So then p into cos of p sine inverse x is y1 into root over 1 minus x square into minus, so p has gone, so this is p square minus, again sine of p into p inverse x, so sine of p into p inverse sine inverse x is y, so then this term can be written as y, and again 1p has gone, so we are left with only 1 by root over 1 minus x square. So 1 minus x square will get cancelled. So then that will be 1 minus x square into 2y1 y2 minus 2x y1 square is equals to minus 2p square y1. So now from overall, can I take out 2y1 common? So if we are taking 2y1 common, so then here 2y1 has gone. So we are left with only 1 minus x square into y2 minus, again 2y1 is gone. So then that is xy1 minus is equals to minus 2y1 is gone. So then we are left with, so we didn't write this y. So that is y1, this value is y1 into y. So this is y by. So y. So then again, so 2y1 is gone. So then we are left with p square y. Or, so this can be written as 1 minus x square into y2 minus xy1 plus p square y is equals to 0. Now as we obtain the relation between y1 and y2, so now I'll apply n derivatives. So applying n derivatives. So if we apply these n derivatives, so then that will be d to the power n into 1 minus x square into y2 minus d to the power n into xy1 plus p square into d to the power n into y is equals to 0. Now for this, here we are having a product of two terms and we are finding out the nth derivative. So then we'll apply Leibniz rule. So if we are applying the Leibniz rule, so what the Leibniz rule says, the derivative of nth derivative of uv is equals to uvn plus nc1 into u1 vn minus 1 plus nc2 into u2 vn minus 2 plus so on plus unv. So that is our Leibniz rule. So now for individual terms, I'll be applying the Leibniz rule. So then u, this is v, so that will be 1 minus x square into y2 of nth derivative plus derivative of 1 minus x square is minus 2x into y2 of think we forgot NC1. y2 of n minus 1th derivative plus NC2 into derivative of minus 2x, that is minus 2 into y2 of n minus 2nd derivative plus or minus, again apply Leibniz rule for this, so that is x into y1 of nth derivative plus nc1 into derivative of x is 1, y1 of n minus 1th derivative, again plus p square into yn, the derivative is equals to 0. So then, if this can be written as 1 minus x square into y n plus 2 plus nc1 value is n into minus, so then this will be minus 2nx into y n plus 1, and again this is nc2 is n into n minus 1 by 2, 2 will get cancelled, minus n into n minus 1, y2 of n minus 2 is yn, and minus x into y n plus 1 minus n into yn plus p square into yn is equals to 0. Now we'll segregate the terms, like writing all yn terms separately and yn plus 1 terms separately. Now if we segregate these terms, so then we'll be getting it as 1 minus x square into y n plus 2, and now from these two yn plus 1 terms, can I take out minus x into yn plus 1 into minus x into yn plus 1 terms common. So if we are taking minus x into yn plus 1 terms common, so then that will be 2n, and here we will be left with plus 1 into x into yn plus 1. And now from all these three terms take out yn. So if we are taking out yn common, so then that will be plus, if we are taking yn common, that is p square, from positive I am writing, and here this is minus n square plus n, and again this is minus n into yn is equals to 0. So plus n and minus n will get cancelled. So then that is 1 minus x square into yn plus 2 minus 2n plus 1 into x into yn plus 1 plus, again this is p square minus n square into yn is equals to 0. So this is what he asked us to prove. Now, so given the curve y to the power 1 by m plus y to the power minus 1 by m is equals to 2x, and is asking us to prove the following derivation, that is x square minus 1 into yn plus 2 plus 2n plus 1 into x yn plus 1 plus n square minus m square into yn equals to 0. And this question was asked in the year July 2013 and as well as July 2015. And the remaining part of this, so we'll derive one equation for y, and from there he has 2 more years. Okay, so what is that? We are going to see that now. Now let us say, given the curve y is y to the power 1 by m plus y to the power minus 1 by m is equals to 2x, or can I write this one as y to the power 1 by m plus 1 by y to the power 1 by m is equals to 2x, and I'll take the LCM for this. So then this will be y to the power 1 by m whole square plus 1 is equals to 2x into y to the power 1 by m. I have taken the LCM and I brought this y to the power 1 by m this side. So then bring this one here, so that is y to the power 1 by m whole square plus minus 2x into y to the power 1 by m plus 1 is equals to 0. So now if we look into this, so it is a quadratic equation in terms of y to the power 1 by m. Now so it is a quadratic equation. It is a quadratic equation in y to the power 1 by m. Now, so this is y to the power 1 by m is equals to 2x plus or minus. Now, from these two terms, I'll take out 4 common. So if 4 is coming out of the root, so that will be 2 into root over x square minus 1 by 2, or the value of y to the power 1 by m will be equals to, so if we take out 2 common, so 2 will get cancelled, that is x plus or minus root over x square plus 1, minus 1. Now, so y is equals to, I'll apply power m on both sides. So as we are getting 2 values for y, so that is one is x plus root over x square minus 1 to the power m, and another is x minus root over x square minus 1 to the power m. Now I'll check out the value of y1 for individual values. Like, let us say if we are taking plus, that is y is equals to x plus root over x square minus 1 to the power m. Now if I apply log on both sides, so power m is for x plus. Now if I apply log on both sides, so then if we are applying log on both sides, so then that will be y to the power, log y is equals to m into log of x plus root over x square minus 1. Now if we differentiate with respect to x, so differentiating with respect to x, so then what do we get? That is 1 by y into derivative of y is y1 is equals to m into derivative of log, that is 1 by x plus root over x square minus 1 into derivative of 1 plus root over x square minus 1 is 1 plus derivative of root, that is 1 by 2 root x square minus 1 into derivative of x square minus 1 is 2x. So here 2 and 2 will get cancelled. So that is 1 by y into y1 is equals to m into 1 by x plus root over x square minus 1 into, now if we take the LCM, so that will be x plus root over x square minus 1 by root over x square minus 1. So x plus root and x plus root will get cancelled. So then that will be 1 by y into y1 is equals to m by root over x square minus 1. So this is the value when we are going with plus x plus root over. Now what happens if we take x minus root over? So let us say y is equals to x minus root over x square minus 1 to the power m. Now as we are having power, so we'll apply log. So apply log on both sides. So then that will be log y is equals to m into log of x minus root over x square minus 1. So then if we differentiate with respect to x, so then that will be derivative of log y, that is 1 by y into derivative of y is y1 is equals to m into derivative of log, that is 1 by x minus root over x square minus 1 into derivative of x minus root over x square minus 1 is 1 minus 1 by 2 root x square minus 1 into derivative of x square minus 1 is 2x. So then that will be 1 by y into y1 is equals to m by x minus root over x square minus 1. And if we take the LCM, so then that will be, so here 2 and 2 will get cancelled. So that will be root over x square minus 1 minus x by root over x square minus 1, or so that is 1 by y into y1 is equals to, so x plus root over x square minus 1, and here I'll take out minus common, that will be x minus root over x square minus 1. So these two terms will get cancelled, that will be minus m by root over x square minus 1. Now here if we are going with plus, so we are getting plus m by root over x square minus 1, and if we are taking minus, here we are getting minus m by root over x square minus 1. Now in both the cases we are getting the same. So what I'll do is I'll square it on both sides. Now squaring both sides. So if we square it on both sides, so then that will be y1 square by y square is equals to m square by x square minus 1. Like, even if we square this term, that will be plus m square, and that implies x square minus 1 into y1 square is equals to m square y square. Now as we got the relation between y and y1, in the same way we'll get the relation between y, y1 and y2. Now in order to get the relation between y, y1 and y2, so we have to differentiate this term again with respect to x. Now, so after squaring and rearranging the terms, we got it as x square minus 1 into y1 square is equals to m square y square. Now I'll differentiate this again, so differentiating with respect to x, so then that will be apply UV formula, that is x square minus 1 into derivative of y1 square, that is 2 y1 y2 plus y1 square into derivative of x square minus 1 is 2x is equals to m square into derivative of y square, that is 2y y1. And now from all the terms, can I take out 2y1 common? So if we are taking out 2y1 common, and from both sides it will get cancelled, so then we are left with only x square minus 1 into y2, and here 1 y1 has gone, so that is plus x y1 is equals to, again 2y1 has gone, so that is m square y. Now, so we got the relation between y, y1 and y2. Now, in order to get the nth derivative, so apply n derivatives. So if we are applying n derivatives, so then that will be d to the power n into x square minus 1 into y2 plus d to the power n into x y1 is equals to m square into d to the power n into y. Now as we are getting the product of two terms and we are finding out the nth derivative, so then we have to go with Leibniz theorem. Now the Leibniz theorem is given by the nth derivative of product of two functions is u into vn plus nc1 into u1 into vn minus 1 plus nc2 into u2 into vn minus 2 plus so on plus un into v. Okay. Now for individual terms we will be applying the Leibniz theorem. Now, so from, as I said earlier, so this question was asked in July 13 and July 15. Now the same question was asked from here. So from here, the same question was asked from here in the year of Jan 2016. So which we have solved it earlier. Now, so we'll apply the Leibniz theorem for the obtained derivative. Now, so if we apply Leibniz theorem for this term, that will be x square minus 1 into y2 of nth derivative plus nc1 into derivative of x square minus 1, that is 2x, into y2 of n minus 1th derivative plus nc2 into derivative of 2x, that is 2, y2 of n minus 2nd derivative. And if we go on further, the derivative of 2 is 0, so then the remaining terms will be 0. Now if we come for the next term, that is d to the power n into xy1. So x into y1 of nth derivative plus nc1 into derivative of x is 1, y1 of n minus 1th derivative is equals to m square into nth derivative of y is yn. Now again, so then this is x square minus 1 into yn minus 2, sorry, n plus 2 plus nc1 value is n, so that is 2nx into yn plus 1 plus nc2 can be written as n into n minus 1 by 2, so 2 will get cancelled, yn plus x into again y1 of nth derivative is yn plus 1 plus nc1 value is n, y1 of n minus 1th derivative is yn is equals to m square yn. Now, so rearrange the terms. That means write all yn plus 1 terms separately and yn terms separately. So then if we segregate these values, so then we will be getting x square minus 1 into n plus 2. Now, from both of these terms, can I take out x into yn plus 1 common? So then we are left with 2n plus 1 into x into yn plus 1. And now, from all these three terms, I will take out yn common. So if we are taking yn common, so then that will be n square minus n plus n, and m square if it comes this side, so that is minus m square into yn is equals to 0. So minus n plus n will get cancelled. So then that implies x square minus 1 into yn plus 2 plus 2n plus 1 into yn plus 1 plus n square minus m square into yn is equals to 0. So this is what he asked us to prove.